Hello kiddos. So I want to go over gas stoichiometry a little bit with you. This is just like regular stoichiometry. The only difference is that we're adding another conversion factor. Okay? Right here. In your notes from last Thursday, it said that 22.4 liters of any gas is equal to 1 mole of that gas. That's our conversion factor. Okay, think of it as molar mass. It's not molar mass, but you're just going to treat it the same as molar mass. With regular stoichiometry, you had to take out the periodic table, you had to add up the molar mass. That value went here, and then 1 mole of the substance was on the other side. Okay, in this case, there's no periodic table. We're not looking anything up. The number is always going to be 22.4 all the time. Anytime we're going from moles to liters or from liters to moles, the number is always going to be 22.4. 22.4 all the time. That is true if the reaction occurs at STP. STP stands for standard temperature and pressure. Okay? Standard temperature and pressure is simply going to be 0 degrees Celsius of temperature. That's going to be our temperature. And 1 atmosphere of pressure. If the reaction occurs at STP, then we can use 22.4 liters for every mole of gas. That's the only difference, okay? Now, I gave you these boxes here. You're going to fill them out, and you're going to solve these problems. So let me work through 2 of them with you, and then 3 of the last 3, you'll be on your own. So let's look at number 1. Given this equation, how many liters of chlorine can be produced for 0.790 moles of nitrogen at STP? Okay, there's that key word, STP. Since it's occurring at this temperature and this pressure, we can use 22.4 liters to the mole. So here is our given. 7.9 moles of oxygen gas. That's what the problem gives us. Okay, so what have I always told you to do with the unit that you're given is in? What have I always told you to do with it? Bring it down. So moles of nitrogen there. Moles of nitrogen there. Okay? What goes on top? Well, the rule is once you have your given in moles on the bottom, then you can use the mole bridge to go to moles of your unknown. So what is it asking us for? How many liters of chlorine? Our unknown is chlorine. So we're going to put moles of chlorine on top. Then we look to the coefficients in the balanced equation. What is the number in front of chlorine? The big number, the coefficient in front of chlorine. 3. What is the number in front of nitrogen? There is no number, so that's just 1. Okay? Now again, what do we do with the unit that's on top in the previous step? We take it down in the next step. So moles of chlorine was on top there. So I'm going to have moles of chlorine on the bottom. What goes on top? Look at the question. What is it asking for? Liters of chlorine. So we're going to put liters of Cl2. Now, we only use the coefficients. We only use these numbers, okay? The coefficients if we have mole on top and mole on bottom. That's our mole ratio. We only use the coefficients if we have a mole ratio. This step, I have liters on top and moles on the bottom. That is not a mole ratio. So what am I going to put for my number in front of moles? 1. This is our conversion factor that I was telling you about. How many liters are in 1 mole of Cl2 gas? What was that number? 22.4. There's your setup. Okay? So on the calculator, you would take your given. Okay, you would have, let me zoom in again. On your calculator, 0.790. Multiply everything across the top. So times 3 times 22.4 and divide it by everything that's on the bottom. Now on the bottom we just have a couple of 1s, so we don't got to put those in. Okay, so we just simply put our equal sign. So 0.790 times 3 times 22.4. I get 53. I get 53. 53 what? 53 what? Okay, well, moles of nitrogen is canceled. Moles of chlorine is canceled. What's left? Liters of chlorine. 53 liters of chlorine. Okay? Just like that. Let's move on to number 2. We go over here. So you'll see I've given you the units all the way down. Your job is just to plug in the numbers. That should help. Plug in the numbers, type them correctly into the calculator. That should help. So let's work number 2. Given this equation, how many liters of oxygen are required to react with 3.26 moles of calcium at STP? So there's your given, 3.26 moles of calcium. Moles of calcium, remember what we do with it? Bring it down. That's exactly what we did here. And then we have moles of our unknown on top. So we have our mole ratio, mole on top, mole on the bottom. So what is the coefficient in front of oxygen? There is no number, so it's just 1. What is the coefficient in front of calcium? 2. Okay? So you move on. Whatever unit is on the top in the previous step, bring it down on the in the next step, but that's what we did. Moles of oxygen is on top, so we bring it down to the bottom. Now this step is not a mole ratio, so we're not going to use the coefficients. So what is the number that we put in front of the mole? 1. How many liters are in a mole? 22.4 liters to a mole. 22.4 liters. Okay, so on the calculator, I'm going to write up top because I'm kind of short on room here. So on the calculator, you're going to type in 3.26 times, we can ignore the 1 and go straight to 22.4 divided by 2. And then again, ignore that 1. 3.26 times 22.4 divided by 2. You don't have to hit equals in between each operation. Just type it in one long sentence. 36.5. 36.5 what? What's my unit? Liters of oxygen, 36.5 liters of oxygen. So I did the first two for you, okay? The next three, you're on your own. Everything's there for you. All the units are laid out. Your only job is to fill in the numbers where they go and type it in correctly in the calculator. Remember, only use these coefficients if you have a mole ratio. How do you know it's a mole ratio? There's moles on both sides of the train track, on top and on the bottom. Only use the coefficients if you have that mole ratio. If you do not have a mole ratio, okay, it's always going to be 1 mole, and it's always going to be 22.4 liters all the time. Okay, just don't get those mixed up. But this is pretty straightforward. You have the rest of these 3 to work out. Thank you for watching, and have a good day.